So the next topic related to this is, what's the difference between this thing called STD error, which is standard error, and margin of error? So here my standard error was 0.875, margin of error was 1.706. In this next example, my standard error was 0.474, my margin of error was 0.932. The relationship between those two is related to that 95% rule we learned a while back. So standard error is the standard deviation of the sampling distribution. It's not the standard deviation of the sample, it's not the standard deviation of the population, it's not the margin of error either, it's the standard deviation of the sampling distribution. So what StatKey did for me is it took all of these 6,000 means I have here, and it applied the standard deviation formula, the same formula that Excel uses or Google Sheets uses. It applied that formula to these 6,000 means, and it said, okay, the standard deviation for these means is 0.474. And the standard deviation for these 6,000 means is 0.875. The standard error for a sampling distribution definitely depends on the sample size. So notice, sample size of 50, I had a standard error of about 0.9. Sample size of 200, I had a standard error of 0.474. Now, every time I redo this, it's going to be a little bit different, but it should always be pretty similar to that. So that's 0.474. If I reset this plot and run 6,000 new samples, each of size 200, this time it's 0.472. It's close, about the same as it was before, just a little bit off in that thousandth position there. All right, so that's standard error. It's just the standard deviation of the sampling distribution. You got to use some technology to calculate it. The easiest technology we have at our fingertips to do this is in StatKey. Could you do it on a spreadsheet? Yes, but it's a total pain. Not even going to go over that. All right, so next, how is this related to the standard, the margin of error? And that relates to the 95% rule, which was also known as the 2 standard deviation rule. And what it says is, if you have a distribution that's kind of sort of symmetric and bell-shaped, and that doesn't even have to be completely true, but it's the usual assumption, where your mean and median are pretty close to each other in the middle there, then if you look 1, 2 standard deviations to the left, so x bar minus 2 standard deviations, and you look 1, 2 standard deviations to the right, x bar plus 2 standard deviations, then in between, if you count up all of the numbers in your data set that fall between this number and that number, then what you should find is there's about 95% of the data in the middle. So if we had a histogram and we counted up all the stacks, how much is in each stack of our histogram, we should find out, and then compared it to how much data we have altogether, about 95% of the data is in there. This gives us the idea of the margin of error for a 95% confidence interval. So margin of error for a 95% confidence interval is twice the standard error. Why the standard error? Because I'm pulling it out of the sampling distribution. So if I look at my previous example, back here, the claim was that the standard error was 0.474. So that means for a 95% confidence interval, my margin of error should be equal to 2 times 0.474. Let's see what my calculator thinks about that. 2 times 474, I get 0.948. Notice that's close to the number here. It's not exactly the same, but it's close. And there's a lot of reasons why it's not exactly the same. Part of it is the idea of these simulations have a little bit of randomness, a little bit of variability. So sometimes that twice the standard error will be exactly what you calculated for the margin of error. Sometimes it's just going to be close. I look at my previous example over here. Yeah, this one. There, my standard error was 0.875, so I can estimate a margin of error. Instead of using StatKey's 95% calculation, I could just say, just take twice the standard error, 0.875. Calculator thinks that is 1.75, which is similar to this right here, not exactly the same, but close enough. And again, it's partially because of variability in the different samples that were drawn 6,000 times. So standard error is the standard deviation of the sampling distribution. Margin of error is related to that standard error. Now there's 4 kinds of standard deviations floating around here, so I'm going to mention those, and then we'll do some more examples. So we have what's called sigma. That's the standard deviation of the population. Remember, standard deviation is the measure of average spread of a data set or population. Generally, this number is not known. Think about it this way. We're doing samples to estimate the average of a population. If we don't know the average, how are we going to know the standard deviation? Because standard deviation is calculated based on the average. So generally, we don't know that. It's just this idea out there. We can't calculate it because we don't know everybody in the population. So we take a sample. The sample standard deviation is called S. And we took a sample, so we definitely know that. Then there's this standard error, SE. And the standard error is just the standard deviation of the sampling distribution, which is related to the sample and the population. Standard deviation of sampling distribution. Next, there's margin of error, which is related to the standard error if it's a 95% confidence interval. So we're going to say the margin of error is about 2 times the standard error if I'm doing a 95% confidence interval. If it's higher than 95%, it's more than 2 times. If we're going for lower than 95% confidence, it's less than 2. And we'll worry about that later. StatKey makes it easy to switch. But based on that 2 standard deviation rule before, that's where this idea comes from here. So these 4 different numbers. And so I'm going to try and show those 4 different numbers back in StatKey, and then we'll move on to another example. Let's see, show desktop. So back to the original baseball data, the 877 baseball players. I got that again from StatKey sampling distribution for a mean down here. So this right here, the 6.334, since these are all baseball players in 2019 Major League, that is what we call sigma, the population standard deviation. If I take a sample from this population of size 10, then I get a different number down here, standard deviation is 0.0645 for this sample of 10 baseball players, that would be S, the standard deviation for a sample. If I then take tons of different samples of size 10, I get a third standard deviation called the standard error here. So right now I have 5,001 samples. Every point here is the average of 10 different baseball players from here. So I have 5,000 averages of 10 baseball players' salaries. Their standard deviation is about 2, right? So this is what we call sigma, standard deviation of the population. We generally don't know that. We do have a standard deviation for a sample, and every one of these samples here has a different standard deviation. 14, 6, 3, 4.4, right? They're all over the place. The standard error is take all of these means here and apply the standard deviation formula from like a spreadsheet. It says it's 2. So that's a totally different number. If we wanted to make a confidence interval, that's when we do something like, say, let's be 95% confident, and then we get the margin of error, which is, now notice this is very unsymmetric. This side is shorter to the mean than that side right there. So here I would call the margin of error the difference, half the difference between 9 and 1.3-ish. Right? That's going to be about 4. So if I take 9 minus 1, that's 8. If I went 2 standard deviations to the right and 2 standard deviations to the left, that's 4 jumps. 8 divided by 4 is 2. So that's that idea about twice the standard error. So on this picture here, I can see all the different standard deviations. Generally, the only ones we're really worried about, we never know the population one, so for now we're just gonna say who cares, but we often will want the sample one. In a couple weeks, we'll come back to looking at that. But this week and next week, we're only gonna care about the standard error here and the margin of error down here. All right, that was a lot. So we're gonna take a couple minute break here and then come back. And then